So today's video I'm gonna talk quite a lot about electrical, dual battery systems, solar, you name it, anything to do with electricity in your four-wheel drive. Actually, this is probably one of my favorite subjects. Got a bit of a background in electrical work. However, I will add a disclaimer: I'm not a car electrician, auto electrician. Anything that I say or do, and anything you do, is all done at your own risk, and I take no responsibility for anything I've done or anything you do. Anyway, that said, let's move on, because it is an interesting subject. However, there are some cautious things we need to be aware of. So what I'm going to do is start off with the dual battery system. So just out of interest, this is a Prado GXL 21 model. You're looking at the standard battery at the moment. Yes, you can see a bit of additional wiring, and we'll go through that in a minute. And then on the other side, I've installed a second battery. That's my dual battery, and this particular battery is something called an SBS. This is in Australia. That's a 105 ampere AGM battery. So obviously there's questions going around about lithium batteries in the engine bay, and I'm starting to see, as of now, some of the manufacturers are starting to produce lithium batteries with a higher temperature rating. Now, I'm not to tell you they can or cannot work within an engine bay, but I'm starting to see them go up as far as sort of 80 degrees now. Whether that's suitable or not, that's not for me to say, but interesting that it's certainly developing in that space. I'm looking forward to it. This battery's got a 3-year warranty. It's about a year old now, so certainly by the time it's up for replacement, I'll be very interested to see where lithium sits at that stage, because this is an AGM. It's 30 odd kilos, bloody heavy, weight in the front of your engine, not good. That said, yeah, it does the job, and it does its job very well. So obviously you've got to charge it somehow. So, you know, when we look at the engine and we look at the power in your alternator, and I'm not going to go into all the different alternators and pulling power, but smart alternators are around now, and basically what a smart alternator does is it senses the voltage on your main battery, and once it's fully charged, it reduces the current being supplied to the main battery, because it no longer needs to charge it. It just provides a floating voltage, and that is all done to meet EU emission standards. The sacrifice for that is that if you were to connect your second battery straight to your alternator, you will be struggling in how you charge it. And I'm not going to go into all the whys and wherefores, because I'm sure everybody's got an opinion of it, but a couple of things to consider. First of all, the distance. So if you run cables across the second battery, you're going to get a voltage drop to your second battery, which means that if your voltage is dropped from your alternator anyway, you know, how much current is it going to get? The full charging current. It will probably charge it, but from what I've seen and heard, is that generally it doesn't reach full charge. However, that said, it's probably good enough, but as I said, each to their own. Then what you do obviously is put an isolator between your main battery and your second battery, and that is to stop you drawing down on the main battery when you're using the second battery to run items when you're camping. So for instance, you know, you pull up, you switch your camping lights on, your fridge is running off your second battery. If you don't isolate it, so disconnect it from your main battery, it will pull power down and it will flatten your main battery. So that's why you need an isolator. There are smart isolators, so ones that will switch on and off automatically. There's all sorts of tech out there nowadays, and some of them are pretty cool, that they'll switch off when the voltage drops or when it senses different voltages. So as I said, those are options. The other option, when you move up the scale and start to invest more money, is a charging system, and what they call a BCDC. Some of them sometimes called DC-DC, but basically it takes the DC voltage from your starting battery or connection from the alternator effectively. So your alternator supplied power to your starting battery. It then takes that power through an intelligent unit that then charges the second battery. And I say intelligent unit because it does have a lot of smart. So generally most of the decent ones now will work with a smart alternator. You just have to configure them accordingly. So you'd set the BCDC up for a smart alternator setting, so it knows when the voltage drops that it's the alternator dropping it and no other reason. And it will maintain the charge to the second battery. And the good thing about the BCDC converters is that they provide a proper charging profile to your auxiliary battery. And charging profiles are very important, because if you just wham your current into your battery, you're not going to get the most life out of it. If you have managed charging through charging profiles within your BCDC, you'll prolong the life of your battery, or get that 3-year warranty that I'm looking for. If you just connect the two together, then you won't, and you won't necessarily get to full charge. So there's a reason you pay your money. You know, you get what you pay for, and smart chargers are certainly the way to go if you can afford it, but they're not cheap. So, you know, and then you've obviously got to fit the thing, so depending how you do that, adds more cost to it. The other good thing with charging BCDC units is that most of them nowadays you can connect solar. And this particular example, you can see I've got an Anderson plug here, which is actually my solar connection. Yeah, I'm not sure it's quite the right place at the moment, but we might look at moving that later. So my BCDC is sitting inside the engine bay, and it's sitting down there, and I have a Redarc BCDC 1225D. 1225, so the 25 means it's capable of 25 amps, because I don't really run inverters. I don't run too much current draw other than a fridge off my second battery and some lights. So I don't have a requirement to provide any more current than 25 amps from the main starter battery. You can get larger units, and of course if you go into a trailer or a caravan, you get into a whole different story. So probably another bit of a disclaimer, this is a dual battery system in a vehicle only. As I said, it's in a Prado. It doesn't supply anything else other than stuff within the vehicle, so we're fairly limited to what we're supplying. So hence the sizing of the BCDC. And I guess if you're going to buy one, you need to think that through, because you don't want to be buying one and then find you need more current later. So work out roughly what you're going to be running off it, and get a good idea of your sizing requirements. So a little bit more about solar. So, you know, you're out on the road, you plug your solar in, it charges, provides power into your BCDC in my case, and your BCDC then charges your auxiliary battery. So as you all know, I'm sure, you know, when you buy solar you get a regulator with it 9 times out of 10. So you can't connect a solar panel directly to your battery, the voltage is too high. It will damage your battery. You need a regulator to regulate that voltage down to an appropriate charging voltage. And the better the regulator, again it comes back to what I've just said about charging batteries, the better it is for your battery, and also the more efficient they become. So just be aware of that when you're looking at the cheap ones. They generally give with them are not much good. However, if you've got a BCDC converter, you don't need, BCDC charger, you don't need a regulator on your solar. So my solar goes straight into that connection, just from an Anderson plug, straight from the solar panels. The BCDC will accept that voltage, no problem at all, and it will then convert it down to charge the auxiliary battery. So regulator not required on solar. However, if you were now to take that solar and plug it straight onto the battery, you need to use the regulator. So it did raise another question for me on a recent trip. You know, you're camping, you're not moving the vehicle for a few days, you're recharging your auxiliary battery because your fridge is running constantly, your lights are running at night. How do you maintain your starter battery? And you know, it did occur to me at the time that, you know, you've got your doors of your vehicle open on and off. Look, you put your internal lights off for sure, so that if you've got doors open all day whilst you're getting stuff out of the car and your fridge is in the back like mine, you make sure your lights are all in the off position, because they're all drawing from your starter battery. And that does raise one issue, that if you don't move or start your vehicle for a number of days when you're camping, you do run the risk of losing voltage drop on your starter battery. So a BCDC is not designed to feed any charge current back to your starter battery. So you've got a couple of options here. Now Redarc offer a smart isolator, and it's a bit of a hidden thing, and I'll try and put a link to the circuit for it, but basically you can buy a smart isolator, the SBI 12D from Redarc. You put it between your main battery and your secondary battery, and then there's a couple of relays they put in, and there's a reason for the relays is to make sure that the charging only occurs at the right time. And what that smart thing isolator does is it basically senses the voltages between the batteries, so that when you've got your solar connected to your BCDC charges your auxiliary battery. When your auxiliary battery reaches full, the smart isolator detects that voltage, and it then cuts off or opens up the circuit to then charge the starter battery. There's probably some other smarts in there, and the relays stop that happening from when the ignition is on. So it actually connects to an ignition to stop that current flow when the engine is running. As I said, I'll put a link to the wiring diagram for it. I haven't put it in yet. You're looking at about $200 for the smart isolator. The SBI 12D is about $200 at best. You need a couple of relays, and you also need some more fuses, and they're probably the most expensive, because in that scenario you need 60 amp fuses. And so by the time you finish that lot, you're looking at 300 Australian dollars to put that in, and if you do it yourself. The other way, and I've heard people do it, is that they connect because they've got their solar with them, and this is what I do. My solar does have I do have a regulator with my solar. I connect my solar straight to my start battery for a few hours using the regulator of the solar panel. It raises another interesting question, and the information I've got from Redarc is that, well, because the question comes up, is that if you're supplying a voltage to your start battery, will the BCDC kick in and think it needs to charge the auxiliary battery? And the answer is yes and no. So yes, it will start because it will see the voltage. So the BCDC will switch on, it'll think it's got a voltage coming in, it'll switch on and start to think it's going to charge the secondary battery. But the big but here is that it's looking for, in this particular case with mine, it's looking for 20 amps. It's not going to get 20 amps, obviously, because the solar's not going to provide 20 amps, unless you've got a big solar panel, in which case I'm talking rubbish. But if you're like me and you've got a 250 watt solar panel, you're not going to get 20 amps coming in. So the BCDC will cut out and say, I didn't get my current that I needed, I'm not supplying the auxiliary battery. And I've got a smart monitoring system, which I'll come to a bit later, and that actually was quite interesting to watch that in those circumstances. You can see it cutting in and out. I don't know, and I've not got the answers. How much does it do it any harm? I'm not aware that it does it any particular harm. I don't think it's something you'd be doing all the time. It'd be very rare. I guess for me, you know, there's a couple of things here. How often do you charge your starter battery when you're out on the road camping? Not very often, but it's there if you need it. The other thing you could do, and one thing I'm thinking of, is actually putting an isolator switch on the cable that runs from my primary start battery to the BCDC, and actually it goes through this fuse here. So I could actually just flick the fuse out, that would disconnect the BCDC, and you'd be able to just charge it. I'm not taking the fuse out because that is one of the fixed fuses, but I might put an isolator in, I don't know. The other thing is, I've only ever needed to do it once, I think, on a trip, when I've seen the voltage start to drop off after a few days. So There are different options there, definitely. Your cheapest option is literally just use the regulator that came with your solder, take it with you and just connect it straight to the starter battery for a couple of hours to give it a bit of a trickle charge or a boost if the sun's out, and that usually does the job. So the next point for discussion, well not really discussion, but for me to talk about, is cable sizes. So cable sizes is probably one of the most important things when you come to vehicle wiring, and all I can say is don't skimp on this, and if you don't know what you're doing, get professional advice or get an auto electrician to do it for you. So the thicker the cable the better, basically, to cut a long story short. So what's the problem with cable sizes? So auto cable, first of all, you need to certainly understand what cable sizes you're putting in and why. You need to understand your current draw and your distance and your voltage drop of the cable you purchase. So all cable that you purchase will have, if you get to the technical specs, a voltage drop. Often it's hard to find, and if you find it at all, on average you're looking at 3 to 4% voltage drop. So what you need to think about is how long is your cable run, how fat is your cable. So 12 volts is low voltage, unlike mains voltage, which is obviously a lot higher. So the low voltage means the oomph, basically to kick the current down the cable, is less. So I suppose it's a little bit like water going down a pipe. If you've got a narrow pipe but you've got a lot of pressure at the end, you can push the water hard through the pipe and it will come out the other end no problem. If you've got a narrow pipe but you've got very little pressure, you get a dribble out the other end. So that's a bit like the voltage difference between 12 volts and 240 volts, depending on the oomph going down. So that's the difference. So you've got completely different cable ratings depending on your voltage. So we're talking 12 volts in my case, DC, so that's a low voltage, so you need a big fat cable to get that down, especially if you want high current. Now if you were following earlier, my BCDC draws 25 amps maximum, so in theory the cable that's needed to connect from my BCDC to my starter battery would need to be able to cope with 25 amps at least. So it's fuse rated at 40 amps, so you're probably looking at saying, well, if the fuse is at 40 amps I need to be even above that, so you're probably looking at 50 amp cable minimum to supply my connection between my BCDC and my starter battery. I'm sure there'll be people argue about that, but this is just my opinion, and I think if you want to really be cautious, the bigger you go the better. So again, distance comes into it. My BCDC is right down here, so it's literally probably half a meter running to my battery. So either to about 50 amps over half a meter, you're looking in cable sizes of possibly something like a 6 AWG or BNS. So BNS and AWG are basically the same size. But that does not equate to millimeters, square millimeters, and there are tables on the internet that will help you through that, but a 6 BNS cable is certainly not 6 millimeters squared, and as I said, tables will show you those sizes. You need to look at the cable that you're buying. As I said, all cables are different. Look at the cable you're buying, look at the voltage drop, look at the current ratings for that cable, and then work out roughly what you need, and then if you're in doubt, go to the bigger size, definitely. So as I said, I've used for myself, I've used 6 BNS, and the smaller the number, the bigger the cable goes. So 6 BNS here to my BCDC, and I've done the same from my BCDC over across to my auxiliary battery. So those cables are in there, and they're obviously all fused. So all the cables are fused, everything's fused where it connects to the live terminal of the battery, and that is really important. And again, go by your manufacturer's fuse ratings and even their advice on the types of fuses. Some of these, and I'm not quite sure the naming, the MPT fuses, you need fuses that are fixed, that don't wobble, certainly when you get into large current ratings. So one of the interesting things about fuses is, and it's the same with mains electricity, if a connection gets loose and you've got high current going through it, it sparks, arcs and gets hot, and that's where fires start. So if you've got just a fuse in a slotted holder like these ones here, and if that's drawing high current, you really shouldn't be using these for high current, even though some of them can be rated at 30 amps. 30 amps is probably maximum. I wouldn't go above that, and that's my personal opinion. So these fuses in here for the BCDC are 40 amps, so they're actually they're the screw down fuses, which I think is called MPT. I'll give you the details. I'll add the details in the on the video for those. And that way, and that's what Redarc also suggests, and they're tightened down and bolted down so that they don't come loose, because you're going to get current passing through those. So we've jumped down the back of the vehicle, and I'm just going to give you a quick rundown on voltage to the back of the vehicle. So this is where your fridge goes in my case, and this is where my light switches are. So I've got a little bank at the back here, which is connected to my auxiliary battery, and you can see at the moment it's showing 12.9 volts, which means it's beautifully healthy, fully charged. And I'll come to charging in a little bit. So this is where I can plug some of my accessories, and I've got some Anderson plugs that are switched straight from here for plugging in auxiliary lights or even a fridge. I've also got another connection here where I've got some 12 volt connector for the fridge, and also I actually do put the fridge on this side. And then I've got some USB points here for charging USB devices here. So these two are connected together, and then the cable runs to the front of the vehicle. And again, you know, cable size is very important. So again, it's all about understanding what are you going to run from the back here, how much current you're going to need to draw, because you need to size your cable. And now we're getting into longer cables, so you know the distance from here could be 4 or 5 meters. So you're starting to talk about a little bit of distance, so you're going to have to take in some voltage drop into this type connection. So current here is much less for me. So I've got a fridge that runs on, actually it's 0.67 amp hours, so it's a very low current draw, and that was one of the reasons why I bought the fridge. I've done a separate video on it. It's the Bushman fridge. There is a video, check it out. Very low current draw, that's the average, 0.67 for running time. Yes, the starter current's more. Now I've only got a couple of small lights that I run at the moment off the back, so we're probably pulling total maximum, I mean less than 10 amps from the back. So again, it's about, I've calculated that out, and I could even say, well, let's say worst case scenario 20 amps, which I'm not going to be anywhere near. You then do your calculations based on that current draw that you think you're going to pull. In this particular case, and this is only my choice, and again just as a guide, I used 8 BNS for this. I ran that to the front. That for me, I feel, will give me sufficient current at least 20 amps over 5 meters. And I'm sure people will disagree with that, but that's my calculation based on the actual cable I bought and the voltage drop of that cable. So it's specific to the cable I purchased. And as I said before, different cables will have different resistance and they'll meet different purposes. So anyway, that's in the back. Again, everything's fused. So this circuit that runs to the auxiliary battery has its own fuse on it, so that if I overload anything on this circuit, that will blow as well. And that's rated accordingly to what I think I'm going to draw. And obviously the fuse is rated lower than the cable size, so that the fuse blows before the cable gets hot. Right, so we're moving on to battery monitoring. So I guess one of the important things is to monitor your batteries. Now you saw inside I had a little digital read of my auxiliary battery, which is great, and that helps me keep an eye on the voltage there. However, I'm using these things called BM2s, and I'll just try and point it out to you. It's this little device here. So basically it sits between your positive and your negative, so you just connect it between the two. I've stuck it to the top of the battery using some 3M all-weather double-sided stuff, and that's actually stuck it really well. I'm very impressed by that. So I've got one of these on my starter battery and one on my auxiliary battery, and these are Bluetooth devices that connect to your phone. So in a second I'll take you to the app on the phone and talk you through how that works. So it's very important, this, I think, because you need to be able to monitor your batteries. Maybe when you're camping, you don't want to have to go in and out the vehicle, but not only that, unless you've got a digital connected to your starter battery, which is one option, and it's not through the ignition, because you need to know what it is when the engine's not on. You don't know what your starter battery is doing either. So I'll show you the app I've got with that. Now these things you can pick up on eBay, BM2s, varying price. You're looking in Australia about $30–35 last time when I bought these anyway. And yeah, literally, as I said, very easy to fit. One piece of advice I would give, if you're like me and you buy two at the same time and want to set them up at the same time, connect one, set one up completely, give it a name in the app before you start the second, because silly me put both of them on and tried to do the both at the same time and didn't realise, I didn't know which one was on which battery. So anyway, bit of a tip for you. We'll look at the app now and I'll show you what these do to keep me informed. So here we are with the battery monitoring app. This is the BM3. As I said before, this is the paid version. BM2, the free version, allows you to see one battery at a time. You can swap between batteries on the BM2, but you have to disconnect from one and connect to the other, so a bit of a pain. For a few dollars, BM3 allows you to see up to 4 batteries on the main screen. Once set up, you can name the batteries, and I've got them auxiliary main. These connect by Bluetooth to the apps that the devices that sit on top of the battery. You're seeing at the moment the vehicle is idle, not running. We've got which is the best time to take these readings, of course. Auxiliary is sitting at 12.72, main battery is sitting at 12.63. State of charge, which is very small but above it, SOC is 99% for both of them, which basically means they're full. So that's really good to see. Down the bottom here you've got things like cranking tests, so you have to be on this screen and you can run a cranking test. It will show you the last main cranking and voltage OK for cranking. When you set this up, you have to tell it whether you're using starting batteries or not. It's set for starting batteries. There is not a setting to set them independently for different batteries, so it'll probably tell you cranking voltage for the auxiliary is not good because it's not a cranking battery. So but anyway, we're only monitoring the main on this one, so that'll check the cranking voltage. So that's basically how much does the volts drop during cranking, so that's in there. This one is a charging test, so once you are actually charging the batteries, so once you're running, it'll tell you how the charging's going on, and you can actually do a charging test. So it takes you through what you need to do, start the engine and start testing. Obviously I'm not on the engine at the moment, so we'll just show you that. And then the graph, which is where we were on the main screen, and I find this the most useful feature, to be honest with you. So from the graph, once you tap on it, just turn it around for you, and you can see how the batteries change over a time period. It's currently looking at a day view. You can change to different views of 7 days and 15 days, and you can generally see that's probably where I've gone to work or driven the car, so that's starting and then driving, sitting in there. And if we go back a week, you'll see the same pattern. And if I take you back to earlier in the month when we were traveling, we can start to look at some proper activity on the graph, and you'll start to see it here. So there's some stuff going on here. Now that's charging going on. So if we go back into a day view, we go back to about the 6th of January. Let's go back one more day. So there's a very good example of fridge overnight cycling. So you can see the wavy line for the purple. That's the auxiliary battery, slowly discharging. So you're looking at or it's fluctuating quite a bit depending obviously when the fridge is on or off. But you can see the slope of the graph. So 12.57 looks to be the maximum up there, and down here we're on 12.47. so certainly you can see a drop off during the night hours, but not as significant. My fridge doesn't draw a lot of battery. Anyway, so you can then see that the solar's been connected, and hence the increase in charge. So the solar's connected there, and I've charged the battery up there, and you can see that it's suddenly reached full at that point, and then its floating voltage is sitting there, and then it's gone into I suspect it was probably disconnected later in the day. I don't think the solar was on all day there, but anyway, you can see that again, different patterns of that's possibly driving movements. So the Redarc is charging, so that'll be the main battery is getting juice from the engine, and the Redarc is charging up the auxiliary battery there. So that's pretty useful. You can set alarms on the batteries. You've got some setups in here in your system setup. You can set your power alarms and your parameters here at what stage you want to generate an alarm. And you can set some notifications up in here, and they'll just notify you on the app. This is where you set the battery type, and then some updates within the bottom here. So there's not much more to it. It's a pretty simple app. I hope you found this useful. Thank you for watching.